welcome to the show. It's me, John Park. It's time for JP's product pick of the week. Thank you so much for stopping by. Hello, everyone over in our chat. We have our Discord chat over there, right there. There it is. And that is at adafruit.it/Discord, and you can jump into the live broadcast chat channel. I'm also keeping an eye over on our YouTube chat. Hello, Dave Odessa. Thanks for stopping by. Hey, Randall Bone. Hello, and welcome, and vroom vroom. Let's see, what have we got going on here? I want to send you to this URL right here if you want to check out this week's product pick before we even talk about it. And that QR code will take you there as well. And hold on one second, I'm adjusting my mic volume. I heard that was a little low. That's better. Let me know if that peaks out too much. So yeah, if you head right there, you will see this product pick, and this show is taking place right inside of the product page itself, so you're safe watching from right within there. And product picks during this show, and only during this show, are on a huge discount. This week's is 50% off, and you don't need a coupon code or anything like that. Just go and grab it. Maximum of 10 per customer. Sometimes we sell out before the show is over, so if it's something you're thinking of getting, I encourage you to grab it. If not, maybe you'll just hang out for the ride and the demo. But before I go any further, let's have Lady Ada jump back just a little bit in time and tell us about this week's product pick. Please take it away, Lady Ada from the past, in your video form.
Okay, so we've got the BNO055. It's actually one of our popular breakouts. This is a sensor that has a 9-DOF accelerometer, gyroscope, magnetometer in it, and it will also give you quaternion and Euler values output. And why is that handy? Well, you can use a microcontroller that's fairly high power, like Cortex M0 or M4, to perform calculations on the fly using 9 degrees of freedom data to get orientation. However, it's kind of a pain. You have to calibrate the sensor, and you have to keep it calibrated. You have to run the algorithm constantly. You have to tune the algorithm. It's kind of like not a fun experience. I mean, you can do it, and it's definitely less expensive. But if you have a simpler microcontroller, like an 8-bit AVR, or something where you don't want to spend your cycles, because you don't want to have your microcontroller constantly on, spending cycles doing calculation, the BNO055 is great for that. It basically just spits out calibration, quaternion, Euler data for you. And we've had a breakout for a while, but now we have it in an adorable new STEMMA QT format. And so here I show you can just plug in one of our cables. It's a power LED. And so this is really nice because you have 4 mounting holes. You can attach it to whatever you want to measure, and then connect power, ground, clock, and data to any microcontroller. And here you can see the XYZ orientation data. If you stay still, it doesn't really move, and then as you twist and move around, it tells you this is the Euler angles. You can also get quaternion, and at the bottom it has the statistics, or the status of the auto calibration. So as long as you see M3, it means that the magnetometer is calibrated. So these are really nice. They're all in one. This uses a Bosch sensor, and then I think Hillcrest bonded a Cortex M0, basically at SAMD 20 is inside of here, which is kind of cool. You could theoretically run CircuitPython on this chip, and it does the calculations and then spits them out over I2C. So people really like these. I will say there's one downside. They have I2C clock stretching, so on Raspberry Pi you have to do a couple things to get them going. But they're very easy to use, and there's a library code support for just about any microcontroller. And the chip we're using on this Feather is one of the slower ones we have. It's at Mega 32U4. So it's an 8-bit microcontroller without a ton of RAM. It's driving the OLED while it's reading this data. It doesn't have to do the quaternion calculations on its own, thanks to this built-in orientation data calculator. So that's the BNO055, now in an adorable STEMMA QT format for easy plug and play with any Python or microcontroller Arduino project.
Yes, indeed it is. Look at it right there. Look at that little beauty. That right there, that's my product pick of the week this week. It is the BNO055 9-DOF Absolute Orientation IMU Breakout. This is the one. This is the one you want if your project involves trying to figure out where you're pointing something, or maybe where you're pointing yourself. The fact that it does the sensor fusion, which is to say it takes the magnetometer, accelerometer, gyro, takes all of that and does the calculations, does the math to figure out where the heck is this thing pointed in 3D space. That's the good stuff. That's the hard stuff to do. And it does it all there on board, and then it can spit out the values you want into your code. So like Lydia said, your code is simpler. Your microcontroller doesn't have to think so much about this stuff. It can just say, all right, hey, sensor, hey, BNO055, where am I pointed? And then do stuff with it. So let's take a look at the product page for this. So here you go. This is the product ID 4646. And during this show, right now, it is half off, $14.98, a great price for a really tremendous sensor. This is one I featured before, and over the life of this product, it has gone through a change from a traditional breakout board to a Stemma QT/Quick type of breakout board. So you can see we have those little plugs on the ends there. It makes it easy to integrate into your project without any soldering, without any breadboards or proto boards. If you're using a board that has a Stemma QT connector on it, you can just plug them into each other. And like we said, that can be a pretty simple board. I'll show you in a moment a little project I put together that uses a QT Py RP2040 as the microcontroller and then offloads all of the tricky where am I pointing calculations to this breakout board right here. If you scroll down a bit, you can see we have some links to a bunch of videos. We have the data sheet for the chip. We have fabrication files. We have a couple of learn guides. The original that shows that bunny demo, that little WebGL bunny demo, which is a really nice way to get started. And then this project, the Power Wash Simulator Nozzle Controller. So this is the one I wanted to show you. I've got it set up over here, and I'll plug that in just so you can see it in action. But here you can see in the code section, there is some info about getting set up with it, getting it set up for your offsets based on where you are on the planet. That'll matter for your magnetometer offsets because it acts like a compass. And then other offsets based on which way your project is in sort of its neutral position. Key thing to this is there is a link to this Adafruit Playground that C. Grover did. C. Grover put together the code for doing very straightforward calibration and offsets for this sensor. So you can get calibrated to start with, and then you can do offsets for your project as needed to give it a relative offset. Other things I wanted to mention. So there was actually a question in the chat about this. The output of the sort of fused sensor data, getting all of these different things together and saying, if my gyro is doing this and my accelerometer is doing that and the magnetometer is doing that, which way am I pointed? And we actually can get two different versions of that. One is Euler calculations, which you can think of as three-dimensional, and then quaternions, which is more like a point on a globe. It's sort of a vector from inside of a globe pointing to any point on the surface. It's usually 4 numbers, at least when I dealt with these in 3D animation. And they can be trickier to deal with, but they do not suffer some of the problems that Euler rotation does, including gimbal locks. There was a question about gimbal locks. Sometimes when you align 2 of the 3 axes, you kind of get stuck and you can't get any info about rotation because there's a order to the rotation. The 0 and the 360 can kind of become the same number as well, and you can get sudden flipping. So gimbal lock and flipping are some issues you will face with Euler rotation, and so that's why quaternion is available. For the project I'm doing, I can get away, which is nice, with the simpler Euler calculations. And so let's take a look at this. So here is, I've got, let me go to a full screen here so you can see the camera a little better. So I've got behind me, this is a PC game called Power Wash Simulator. Just like any first-person shooter game, we're pointing some sort of a gun. We want to be able to aim that thing, right? So we want to know where in 3D space am I oriented. We can even also use things like roll if we want, but for this one, we just want to know which way am I pointed at this screen here. And so this little BNO055 is mounted inside of here, along with the cutie pie and a couple other goodies. So what I'll do is plug this in, and when it recognizes it, it's going to use the direction I'm pointing as its sort of relative starting point. So you can see, even though I'm not pointing at my monitor back there, I was able to get the orientation to work. And there's a little bit of lag in the video here, but this is fun. This is go clean up a really disgustingly dirty house, and I'm also using a little Wiimote there to move around. But you can see I can point this thing up, I can point this thing down, I can go left, I can go right. That is all based on, let me set that down so it doesn't flip out. That is all based on those Euler values that are being spit out for my absolute orientation. Where am I pointed? And then some relative offsets based on the fact that I wasn't actually pointing at the screen, I was pointing away from the screen. But that's all taken care of in code. So let's see, what else have we got? Code-wise, we'll look at just a little bit here. This is a big project with a lot of code doing a whole bunch of different things, but some of the key stuff you'll see here, we set this up by just importing this driver. This is in CircuitPython. We can also use this in Arduino. So you can see here I'm bringing the BNO055 library, and then I am setting it up to use I2C. Here I'm creating an object called sensor. Sensor equals Adafruit BNO055, 055 over I2C. And then we can also set modes based on what info we want to get off of it. So I'm using N-DOF, which is the 9-DOF multiple, all the sensor fusion, give me all the info you can version of it. But you could use it just simply as a magnetometer or simply as a gyro or an accelerometer if you want to. There's a few different modes there. And then there's some math being done here. This is some stuff that C. Grover worked on. Thank you so much to calculate reference points based on your relative and absolute. And here you can see we're also setting up these magnetometer, gyro, and accelerometer values, so we can see those or use them on their own if we want. And then the main loop of the program here, we're just simply saying sensor Euler equals sensor.Euler. So that's how you ask for it. You can just say, hey, give me that position I'm pointed to and roll in space, and it'll just spit back those values as a tuple for you. And I'm breaking those up into 3 separate variables to make them easier to use in code, which is heading, roll, and pitch. And so you can see there are some nice examples in both the main guide and in this setup part of this guide, as well as this playground, on doing like what you saw in Lady Ada's demo, which is just saying, hey, tell me where am I pointed on the compass, or what are those 3 values that I'm getting back. This project is, I think, really nice because it combines all that stuff into what I really want when I use something like this, which is where am I pointed? That's actually much harder to get than you think. In fact, the main other way that this works well is, if you remember on the Wii controller, pointing at a pair of infrared lights. There's a little camera, it's pointing at a pair of infrared lights, and it was doing some math to figure out if we're moving closer or further, then those 2 lights will change their distance between them. And if we are seeing them do this kind of stuff, we're tilting left and right if we're aiming at one or aiming at another. So that works really well, but it does require that secondary setup of a emitter source, the 2 IR LEDs, whereas something like this is really fantastic for having just a single solution that can give you the orientation of your object in space. Let's see if there's any questions. Mike says, I'm guessing Euler anglers come from the quaternions and there wouldn't be a gimbal lock issue. Todd was saying the datasheet indicates that it's doing real quaternions, which is good, and not just faking it. Yeah, so that's a great point. If it's starting from the real proper quaternion and then giving you the Euler values, then it's not as likely, or maybe it won't experience gimbal lock, which is great. Yeah, okay. I think that is it. So let me know if you have any other questions in the chats. If you want to go pick some of these up, head right here to that product ID you see, 4646. Are they still in stock? Yes, they are. They are in stock, and they are only $14.98 right now during the show. You don't need a coupon code. Just throw them in your cart, and you'll get them at that price. And here, by the way, since I set it up, I wanted to show you. Here's some nice close-up images there of the board. So you can see you can solder header pins to it and put it into a breadboard or put it onto a perma-proto if you want, depending on the type of project you're doing. Or you can simply plug into those Stemma QT ports that are on the sides. Is that it? I think that does it. So thank you, everyone, for... People are making jokes about sandwiches. Mike Jones. Euler was eating a gyro. I wanted to know which way it was pointing one time. Hiro? Gyro? Hairbrain says, mechanically, I don't think MEMS gyroscopes are susceptible to gimbal lock, as our gimbals don't really rotate. That's a good point. It's not a mechanical thing. It is separate sensors. So I'm thinking old-fashioned. So yeah, I think we're safe from gimbal lock. That would be good. Okay, that's going to do it then. So if you want to get one of these or up to 10 of these, that's the limit at this price, head on over to product ID 4646, throw them in your cart, get them before the show is over or within a few minutes grace period, and you can get started on some of your orientation types of projects. Let's see, I think I hit all the notes. Yeah, that's going to do it. All right. Thank you, everyone, so much for stopping by. That right there, I wanted to get it right side up, which makes sense. That right there is my product pick of the week this week. It is the BNO055 9-DOF Absolute Orientation IMU Breakout Board. Whew! Thanks, everyone. I will see you next time. Bye-bye.